Hey guys, today we will be working on very difficult AP Calculus AB questions, which contains integrals and rate in and rate out questions. And before starting to our video, you can like and subscribe in order to support my work. Also, if you're interested in tutoring, I would love to help you out. Keep that in mind, and let's just get started. Welcome everybody. This question is from 2005 AP Calculus AB, and question number 2 asks: a water tank at Camp Newton holds 1,200 gallons of water at time t equals 0 during the time intervals t less than or equal to 0, greater than or equal to 0, less than or equal to 18 hours. Water is pumped into the tank at this rate, guys. So basically, keep this in mind. We will just write this in our calculator. This is our rate in. And also it says that this is our rate out. And the question A is asking, is the amount of water in the tank increasing at time t equals 15? Why or why not? So, and there are a bunch of questions as well. First of all, let's start with question A. How can we solve this question? Well, since this is the rate in, guys, and this is our rate out, what we're gonna do is we're just trying to determine the amount of change in this function. So basically, we're trying to calculate, is the water getting in or is the water getting out at time equals 15, and why or why not? We're just gonna give a logical explanation. So guys, I would like to emphasize that this is a rate in and this is a rate out. So what we have to do is we're gonna subtract our rate in, our rate out, W15 from our all rate in. So W15 minus R15. Why I'm saying 15? The reason why I'm using 15 as my domain is because we're looking for time t equals 15. So we're just gonna say W15 minus R15 equals to what? If it's 0, it means that it's not changing. If it's positive, so if it's greater than 0, it means that it's increasing at time equals 15. And if it's less than 0, it's just decreasing. So let's just put this into our smart calculator. Uh, yeah, y, we enter to y, and we enter our first graph. All right, guys, so I just wrote these equations into this calculator, and then what we're gonna do is let's just quit, and then we're just gonna say y1 alpha trace in order to get our y's. Y1 was my rate in, which is W, so I'm just gonna say y1 of 15, which is W15. I'm just doing this equation over here, it's just the same thing, minus alpha trace y2 and 15. So give me an answer. It's negative equals to negative 121.090. Therefore, since this is less than 0, guys, this is less than 0, it means that A decreasing, or no, you just can't say no. It's because, is the amount of water increasing? No, it's not. Because you just can simply say W of 15 minus R of 15 is equal to 1 minus 1 negative 121 121.09, which is less than 0. So you just can say this and then skip to the next question. So let me just erase this. Alrighty, question number B. To the nearest whole number, how many gallons of water are in the tank at time t equals to 18? So guys, first of all, initially, we have 1,200 gallons of water in our tank. So you have to consider that. After that, what we have to do is we have our rate in and rate out, but we don't have the amount of water. How can I find the amount of water at time t equals to 18? So basically, guys, we're just taking the integral of the rate in to 0 to 18, since we're taking at time t equals 18. So we're taking until the time 18. And WT dt minus integral 0 to 18 R of t dt. So guys, why did I take the integral and why did I subtract R dt? So basically, guys, since we have our rate in, we have to find how much water we have. And in order to find that, we're taking actually the area under the rate in curve, and that's going to give us our amount of water. However, the reason why I subtract r of t dt integral is because this is our rate out, and we don't want that. We're just getting rid of it. That's why we just have to write this into our calculator, and I just wrote it down. It gave me an answer of 1309.78. So this is wrong, guys. If you just write this, you lost the point. Why? It's because they say to the nearest whole number. So you have to say 1310. That's your answer. Now let's just move on to question number C. At what time t for 0 less t greater than is the amount of water in the tank at an absolute minimum? Show the work that leads to your conclusion. All right. So what time do we have the absolute minimum, guys? So what I want to do is W t minus R of t equals to 0. So basically there are a few conditions to find absolute minimum, guys. So basically we make our chart, and in our chart we enter our t values, t time, and water. Okay. And we're just gonna find for these specific times. But what specific times? So first of all, since it's saying 0 to 18, we're taking these points, 0 and 18. And after that, we're just gonna find this equation's t results, which means they're intersections. So we can find our t values. And that means that at that specific t values, the rate in and rate out are totally equal, and we might have an absolute minimum or a maximum. The reason why I can't say whether it's absolute minimum or maximum is because we're unable to determine that as this formula. But what we can do is we're just gonna write these answers down, and then we're gonna compare them. So simultaneously, after we compare those values, we're just going to be able to determine where it is at absolute minimum or maximum. So let me just change this chart. So before writing your chart down, guys, you have to first of all make sure that you graph this. And I just graphed it, and I got two t values. I got 6.4998 and t equals to 12.9748. So you should get approximately the same t values as your intersection points. After that, we're writing our chart down. Okay, 1, 2, 3. How many numbers do I need? 4. Okay, I just can use this. And I'm just gonna say 0 at t equals to 0. I already know how much gallons of water do I have. It's 1200. And at t equals to 18, I know that I got approximately, actually I got 1309 point, I don't know, 7 something. And how can I find for 6.499 and 12.97? So guys, we're just doing the same procedure. So we're just writing 1200 plus integral 0 to 6.499 r of t, I'm sorry, w of t minus integral 0 to 6.442 r of t. So since I already have that in my calculator, I'm just gonna take it, and I'm just gonna change my last points because that's the only difference. 6.499, that should be approximate enough to give me a correct answer. And also for this one, 6.499. So guys, what I did, first of all, initially I had 1200 gallons of water. Over here, this is my rate in until the time of 6.499. Why did I use 6.499? It's because that's the intersection point of this rate in and rate out, which gives me either absolute min, or absolute max, or nothing. So we're just going to compare them. And after that, we got our second rate out. And then what will this give me? I just used it on my calculator. And yeah, so I got 500 and I'm sorry, 525.24. And now we're doing the same exact procedure for the 12.97. Yeah, 12.97. So we basically change our endpoints for our integral, which is 12.97. And let me just write this down, 12.997. And this should give me a proper answer, hopefully. Yeah, we're waiting. Yeah, I got 697.43. So our absolute max will be 12.97, and our absolute min will occur at t equals to 6.499. And guys, this chart will be enough for your work, which says show the work for that leads to your conclusion. You just can show this graph. This will be enough to show your work. So now let's jump to question number 8. Question number, I'm sorry, D. For T greater than 18, no water is pumped into the tank, but water continues to be removed at the rate R of T. Until the tank becomes empty, let K be the time at which the tank becomes empty, right? But do not solve an equation involving an integral expression that can be used to find the value of K. So what can we do is, first of all, guys, remember that at t equals to 18, we got approximately 1310 gallons of water because we already calculated that at question B. So since it's we're initially starting at t equals 18 and we're going until we run out of water, that's why we're just going to set this equal to, or you, in other words, you just can take the integral 18 to k because they're saying k, r of t. Why did I use R of t? Because the question says that we're not increasing the water amount anymore, so we're not going to use R W of t, and we're just going to subtract this from 13010, and it's because we just initially started with 13010, so 1310, yeah. And that's why we should end up with 0. Why 0? Because it says at which the tank becomes empty. So we're just going to subtract this rate out until we don't have any water anymore. So it's asking for this k value. Basically, you should solve this integral and you should be good to go. So 13, I'm sorry, oops, this shouldn't have gone there. Yeah, math 9, integral 18. Actually, yeah, so basically, guys, they said that you don't need to solve it. I was almost solving it. So write but do not solve. So basically you just have to write this as your answer choice. So that was it for today, guys. I believe these questions are very helpful, especially for your AP exam in May. And if you have any questions or concerns or anything else, you can just write that down on the comment section. And please let me know if there is any other kind of, topic or concept which you want me to go over it so we can, prepare for our new AP exam. And thank you for watching. Have a good day.